Welcome to this lecture of numerical analysis. In this lecture, we will study the Newton's general formula of interpolation. Before this, we have also studied Newton's formula of interpolation as well as Lagrange's interpolation formula. But both of those formulas had a disadvantage that if another interpolation point were added, then the interpolation coefficients will have to be recomputed. We therefore seek an interpolation polynomial here, which has the property that a polynomial of higher degree may be derived from it by simply adding new terms. Newton's general interpolation formula is one such formula, and it employs what we call the divided differences. So here we first define the divided difference, and then we see how the Newton's general formula of interpolation is used or constructed. It's a problem. Y of x is a function that is not known explicitly, and let x0, y0, x1, y1 to xn, yn be the n plus 1 points lying on phi of x. Then the problem here is to determine a polynomial function that passes through these endpoints. But now in Newton's general formula of interpolation, it will have the advantage that a polynomial of higher degree can be obtained from it by simply adding new terms. So before doing this, we will define the divided differences. So the divided differences are defined in this way. So define a notation. We have a notation like this. We have a notation. So let's define this notation for like the pointers x0, y0, x0, x1. The notation is defined in this way. This is defined as y0 minus y1 divided by x0 minus x1. So this divided difference has a notation in the brackets like x0, x1. Similarly, suppose if we want another example for this, let's take the difference x2, x3. Now according to this notation, this will be defined as y2 minus y3 divided by x2 minus x3. So this is how we denote these divided differences. Now let us define them explicitly and properly. Let x0, y0, x1, y1, so on, xn, yn be given. Be a given collection of points. Be a collection of points. Then the divided differences are defined by the relations. Then divided differences of orders say 1, 2, so on up to n are defined as, so first of all we define a divided difference of order 1, which is now here denoted by x0, x1, and this is defined as per this above definition, this is y0 minus y1 divided by x0 minus x1. Or we can even use like y1 minus y0 divided by x1 minus x0. It makes no difference. So this is divided difference of order 1. Similarly, now this divided difference of order 2 is defined as x0, x1, x2. Now this will be defined as x0, x1, then minus x1, x2 whole divided by x0 minus x2. Similarly, we can define the next, the nth order divided difference x0, x1, x2, so on, xn. So this will be defined as x0, x1, so on, xn minus 1, then minus x1, x2, so on up to xn whole divided by x0 minus xn. So these are the divided difference of order 1, 2, and n. Similarly, we can, using this general formula, we can also define the divided difference of order 3, 4, and 5, and so on. So now let's move towards Newton's general formula of interpolation. Now using these divided differences, we have the first x0, x1. So this x comma x0, this is equal to y minus y0 divided by x minus x0, which gives, we will compute y from this equation. This will give us y equal to y0 plus x minus x0 into x comma x naught. So let's call this as equation number 1. Now similarly we can use the divided difference of order 2. Again, this is x naught x1. Now as per the definition of divided difference, this can be defined as this is equal to x comma x naught minus x naught x1 whole divided by x minus x1. Now multiplying this gives, which gives this x comma x naught, this is equal to x naught comma x1. Now this is just manipulation of the terms to the left and the right hand side, plus x minus x1 into this x comma x naught comma x1. Now we already have the value for this x comma x naught here, so we can substitute this value x comma x naught here, or we can use equation number 1 here to obtain this equation now, which reduces to which reduces to this new equation, which is defined in this way: y equal to y naught plus x minus x naught plus into x naught comma x1, then plus x minus x naught into x minus x1 into x naught x1. So this is what we are doing. So here actually on the left hand side we have substituted this y minus y naught divided by x minus x naught, then multiplied it on the left hand side, so this x minus x naught will get multiplied to this x naught comma x1, which is here. Then this y and y naught are similarly adjusted, and we obtain this equation by just replacing this value for x comma x naught here at this point. So let's call this as equation number 2. Now proceeding in this way, we will obtain this y is equal to y naught plus x minus x naught into x naught comma x1 plus x minus x naught into x minus x1 into x naught x1 x2, then similarly plus x minus x naught x minus x1 x minus x2 into this notation for the divided difference x naught x1 x2 x3, then plus so on, plus the nth term will be like this: x minus x naught x minus x1, then so on x minus xn, then multiplied by x comma x naught comma x1, so on up to xn. Now this last term is actually known as the remainder after n plus 1 terms, right? So this is the Newton's general formula of interpolation, which is the Newton's general formula of interpolation, and the last term being the remainder after n plus 1 terms. So actually this nth equation, which let's call this equation number 3 now. This equation number 3 has actually n plus 2 terms on the right hand side. This is the first term, second term, third term, and so this will be the fourth term, and this is the n plus second term. So therefore this n plus second term, before this we will have n plus 1 terms, and this last term is called the remainder after n plus 1 terms. So this is the general formula of interpolation. Now let's use the general formula of interpolation on a proper exercise and see how do we use it. So we have an exercise like this. So let's begin to solve the question, and we will solve the question in this way so that we can properly understand what is the advantage of Newton's general formula of interpolation over the previous two formulas like Newton's formula and Lagrange's formula, so that we can properly understand the advantage. So what we will do, we will first compute the polynomial using Newton's general formula of interpolation using only the first 3 points. So we'll first compute the polynomial using only the first 3 points, assuming that we have missed to include this last point 6 comma a22, and then we will include this 6 comma a22 after we have completely computed the polynomial using the first 3 points. So that is the only advantage with Newton's general formula of interpolation, which is not the case for the other two formulas given by Newton and Lagrange. In fact, for Lagrange's formula for interpolation, if we compute a polynomial using the first 3 points and we have skipped the 4th point, then in order to include this 4th point in the Lagrange's formula for interpolation, we will have to recompute all the polynomial from the beginning. But now that will not be the case in Newton's general formula of interpolation. So let's begin writing like this. We write x naught y naught as minus 1 comma 3, x1 y1 as 0 comma minus 6, and we name x2 y2 as 3 comma 39. We can compute the polynomial using all the 4 pointers right from the beginning, but we will deliberately skip 1 point so that we can learn the advantage also. Okay, so now let's compute the divided differences. Okay, the divided differences are, okay, so the Newton's formula gives, since we are given 3 points here, so we will have a quadratic polynomial. We will have a polynomial like this: y is equal to y naught plus x minus x naught into x naught comma x1 plus x minus x naught into x minus x1 into x naught comma x1 comma x2. We will not write the last remainder term which was given in here in equation number 3rd. So last term is just a remainder, we don't need to write it here. So we write y naught second term and x minus x naught into x minus x1, x naught, x1 and x2. Now here we need to evaluate what is this x comma x naught and what is this x naught, x1, x2. So now let us begin by evaluating these equations. So let's call this equation number 1. Okay, so now this x naught, x1, this divided difference, by definition this is equal to y naught minus y1 divided by x naught minus x1. Now using the values of y naught is equal to 3, y1 is equal to minus 6, so y naught is equal to minus 6 divided by x naught, this is equal to minus 1 minus 0, so this finally becomes minus 9. And now the second one, for x naught, x1, x2, we also need to compute what is x1, x2. So let's compute x1, x2. This will be equal to y1 minus y2 divided by x1 minus x2. So now using the value, this minus 6 minus 39 divided by 0 minus 3. So this is equal to minus 45 divided by minus 3. So this finally becomes plus 15. So therefore we can compute x naught, x1, x2. Now by definition this is equal to x naught, x1 minus x1, x2 whole divided by x naught minus x2. So this is equal to now x naught, x1, that's minus 9 minus 15 divided by minus 1 minus 3. So this is equal to minus 24 divided by minus 4, which is equal to 6. So we have computed all the things for, so we are ready to now substitute these values in equation number 1. So therefore from 1, thus from equation 1 we obtain y is equal to y naught. Now y is equal to, anyway, let's write the full equation first. Y naught, okay, we will not write the equation, we will just substitute the values. Y naught is equal to 3 plus x minus x naught. So x minus x naught is equal to minus 1, so this becomes plus 1 into x comma x naught. X comma x naught was computed to be equal to minus 9, so this is equal to minus 9. Then plus x minus x naught, that is equal to x plus 1. Then second x minus x1, that is equal to x minus 0 into this x naught x1, that's equal to 6. So we just substitute these values, which is equal to, now using these values, this is equal to 3 minus 9x minus 9, then plus 6x into x plus 1. Now multiplying all these values, we obtain the final equation as 6x square minus 3x minus 6. So this is a polynomial passing through these first 3 points. Now in order to verify whether we have properly computed it, we can just substitute the point -1 here. So if we substitute -1 here, we get 6 plus 3 minus 6. So that is equal to 3. So that is equal to 3. And so this is the correct polynomial. But as discussed earlier, we will now incorporate the last fourth point into the polynomial that we have obtained here in equation number 3. So let's call this as equation number 3. Now assuming for some reason we had missed to incorporate this point. So assuming that, this is just for the learning purpose, assuming that one more data point is available, then we can add this point to the polynomial obtained in equation 3. And how we can do it? So now let's call this new point 8 comma, sorry, that is not 8, that is 6 comma 822. Let's call this new point 6 comma 822 as x3 comma y3. x3 comma y3. Therefore, in order to incorporate this point, we need to calculate. So now we calculate the new differences like x2, x3. We have already computed the difference x0, x1, now x1, x2, and now we will compute x2, x3 also, which is defined as y2 minus y3 divided by x2 minus x3. So this is equal to 39 minus 822 divided by x2 minus x3, that is equal to 3 minus 6. Now this finally becomes 261. And similarly we will compute x1, x2, x3. Now this will be equal to x1, x2 minus x2, x3 whole divided by x1 minus x3. Now x1, x2, that was earlier obtained as 15 minus, now this is 261 divided by x1 minus x3. Now x1, as we know, x1 is equal to 0. So this is 0 minus 6 because x3 is equal to 6 now, and this finally becomes 41. And similarly we will compute x0, x1, x2, x3. Now by definition this will be equal to x0, x1, x2 minus x1, x2, x3 whole divided by x0 minus x3. Now using all the values, this becomes 5. So therefore the expression in third becomes, therefore expression in equation 3 refines to y is equal to 6x square minus 3x minus 6. Now plus x minus x0 into x minus x1 into x minus x2 into this x0, x1, x2, x3. So this is equal to 6x square minus 3x minus 6 plus x0 is equal to minus 1. So this becomes x plus 1, x minus 0, x minus, so what is x2? x2 is equal to 3. So this x2 is equal to 3, and now this x0, x1, x2, x3, this computed here, this is equal to 5. So this becomes now 6x square minus 3x minus 6, then plus, now this is equal to 5x cube minus 10x square minus 15x. So this is just the expression for, so this product is equal to this product. Now finally adding these terms, we get 5x cube minus 4x square minus 18x minus 6. So this is the final answer, which is actually a polynomial passing through these given 4 points. So this was all about the Newton's general formula of interpolation.